I actually have been discussing about the concept of algorithms. Okay, so there we have seen what are algorithms and what is the need for an algorithm. Okay, when I consider we have many data structures and why exactly you need algorithm along with that, why you have to learn it, all those things we have seen there. And apart from that, we have gone through some of the concepts like characteristics of algorithm, then data flow of algorithm, issues of algorithm, and importance, like regarding the practical importance and also the theoretical importance of knowing the concepts on those both aspects. And then factors of algorithm. Then we were actually discussing about the approaches of algorithm. Okay, yeah. So we have already discussed the four approaches of algorithm. Okay, so approaches of algorithm is nothing but when I say we have already discussed like why exactly we need algorithm. So now approaches of algorithm means in what and all way you can develop a solution for a particular problem. Okay, problem might be complex, problem may be simple. So for depending upon the problem, how you can or depending upon the problem, what you can do. Okay, or what should be the approach for writing an algorithm. Okay, yeah. In that concept, we have seen the four different approaches of algorithm. Like the first one was brute force attack. Okay, or sorry, not attack. When it comes in a cyber security, when they use those algorithm, brute force algorithm, we call it as brute force attack. So here we call it as brute force algorithm. Okay, then we have seen greedy algorithm. Then we have seen divide and conquer algorithm, and we have seen dynamic programming algorithm. Okay. Now, next we will see the fifth approach of algorithm is branch and bound algorithm. Okay. Now here, if I see the image, okay, branch and bound. So let's go through this. The branch and bound algorithm can be applied to only integer programming problems. Okay. Yeah. So now here, as I've told you, different approaches of algorithm, how I can have different approaches for. So now here, with the concept of branch and bound algorithm, I can just say that when the type of your solution or the type of your problem to which you are going to create the solution, if it contains the integer, then we call it as an integer programming problems. Okay, so for those kind of problems, we can use the branch and bound algorithm. So how it is working? This approach, it divides all the sets of feasible solutions into smaller subsets. Okay. So, like for example, in not in greedy algorithm, in dynamic programming, what we have been doing is there will be a problem. You will be dividing it into sub problems and will be finding the solution. So it had that memorization power, correct? That functionality was there. In branch and bound, what happens is the solutions we will be putting it into the smaller subsets. Okay, we are dividing all the sets of feasible solution for a particular problem into smaller subsets. Okay, now these subsets are further evaluated to find the best solution. So it's not like in divide and conquer, what we are doing there, we divide the sub problem, we find the solution. Okay, once we find the solution, what we do is we combine them to get the solution for the main problem. Okay, for the complex problem. Now in greedy algorithm, what we do is we will always be finding in each iteration the best or the optimum solution we'll be finding. So here what happens is we are dividing the solutions itself. Okay, the feasible solution for a particular problem will be dividing it into smaller subsets. From that, we will be considering, we are evaluating all those things with our problem. Okay, whichever is the best solution, we will be finding from that. So this is just an introduction of different ways of approaches of algorithm. Okay, when we actually delve into the algorithms, we will be learn more about it, how each and everything is working with the implementation. Okay, yeah. Now next we have is randomized algorithm. Okay, now here we can see um, there will be many what solutions. Okay, those will be divided, and at the end, no, one particular solution was there that is infeasible, so we stop there. Okay, now again coming further, at the end you can see integer feasible UBD dominated by UBD. So this is nothing but the bound. Okay, it's a branch and bound algorithm, so it's working with the integer problem programming problems. Next is the randomized algorithm. So as we have seen in the regular algorithm, we have predefined the input and required output. Okay. So in the data flow itself, we are considering what output I want to get, what input I want to get, everything I'm planning there. I'm preparing there, correct? Okay. So for a particular input, I have to get a particular output. Then the processing unit is working fine. I'll be considering it like that. Okay, if I consider that data flow of algorithm. Now, those algorithm which we consider it as the regular algorithm, those algorithms that have some defined set of inputs and required output and follow some described steps are known as deterministic algorithms. Okay, those are deterministic algorithm means always we have some determined input and output, predefined input and outputs are there. That's why we call those algorithms as deterministic algorithm. And now there are some set of algorithm which I call it as randomized algorithm. Now we'll see what is randomized algorithm. Okay. Yeah. What happens that when the random variable is introduced in the randomized algorithm? Okay. Yeah. So in the image here we can see this is the data flow of deterministic algorithm, and this is the randomized algorithm structure. So input is given, you will be getting the desired output. But in randomized algorithm, input is given, and then a random variable will be added onto the algorithm once you put the input towards the algorithm, and you will be getting the output. So let's see, in a randomized algorithm, some random bits are so in a randomized algorithm, some random bits are introduced by the algorithm. And yeah, so here the random bits are introduced by the algorithm. Okay. We are giving the input, and it will algorithm after processing will give the output. Okay. Yeah. So and added in input to produce the output, which is a random in nature. So the randomized algorithms are simpler and efficient than the deterministic algorithm. Okay, it is simpler but efficient, but for the different purpose, for most of them we need deterministic algorithm, but in some cases we may need randomized algorithm. So these are the different approaches in which how you can create an algorithm. So it's not like for all the problems you use only one solution where the data flow goes like problem, then what input algorithm, I mean processing unit, sorry, problem algorithm, input processing and output we have seen, right? That is data flow of algorithm. So it's not like you have to follow the same thing. There can be different ways in which how you can build an algorithm. So these are the different approaches. Okay. Now, next, the last one is backtracking. Okay. So, to say about backtracking, this backtracking is an algorithmic technique that solves the problem recursively and removes the solution if it does not satisfy the constraints of a problem. For example, there is a problem, okay, and I have a solution. Now, this solution, I will be dividing it into multiple sub solutions, okay, some feasible solutions. Okay, so what I do is I'll be checking all those feasible solutions. For example, in branch and bound, okay, you will be branching all the subsets of the solutions, and then you will be checking. You will be evaluating the solution, correct? And what is the best solution? You take it out from there. But backtracking, what it does is it will go there and it will check for all the feasible solutions, whatever we have, and it will see whether if you fine tune it a little bit, okay, from wherever you are coming, and it will go back and it will check, okay, if I do some changes into this, will this become a feasible solution? So that is backtracking. Okay, so what happens is recursive solution if it does not satisfy. Okay, so one by effectively it will be checking whether this what solution whatever we have will be met for a particular constraint, or whether it is meeting a particular constraint what we have while building a solution. So every time it go back and forth and it will check whether it becomes the optimum solution. So if it is not, then it will be just the solution will be removed from there. So that is about the approaches of different approaches of algorithm. Okay. Yes. So we have seen total of 8 approaches for an algorithm. That is uh, backtracking algorithm. Okay, from the recently learned algorithm algo. So backtracking we have seen. Then we have seen branch and bound. Then we have seen randomized algorithm. Okay. Before that, we have learned about dynamic programming algorithm, and then the divide and conquer method. Okay. Yeah. So the next concept is about the major categories of algorithms. So what are the major categories of algorithm? Okay, like we have many different approaches in which I can develop an algorithm. Now, when I say algorithm in DS, okay, when it comes along with the data structures, what are the different algorithms we are having? So sort, search, delete, insert, update, all these are the algorithms. So these things we have learned as a operations what we perform on data structures. Okay, now in order to perform operations, we need a step-by-step instructions. Okay, so who is providing that? It is provided by the algorithm. Correct? Algorithm is nothing but the step-by-step instruction to do something. So here I want to do something, or I want to perform an operation on a particular data structure. So that is nothing but in data structures we call these things as the operation performed on the data structure. Now here I'll be considering it as some major categories in the algorithm. Okay, there are many different algorithms. For example, if I say in the search algorithm, there are many algorithms. Okay, sorry, not in the search. In the sort algorithm, there are many algorithms. Okay, no, if I take both the things in sort, search, everywhere, there are many algorithms. Okay, out of that, one or two algorithm may be having the approaches. One of the approaches what we have learned earlier. Okay, like divide and conquer method will come. Like in binary search, what happens is we will be dividing into half, half. Then you are trying to get it. And for example, if proper divide and conquer will happen in merge sort. Okay, we'll be merging the things once you did the division, like that it comes. So we'll learn each of them one by one. Now here comes the major categories of algorithm. Earlier one was the approaches in which you can solve. So now using those approaches we can have many different algorithms in these categories. Okay, so first one is sorting. So algorithm developed for the sorting the items in a certain order. Okay, you can have, we will see that, like for example, if I want to say about the sort, we have bubble sort, quick sort, merge sort, many different sorts are there. Okay, next is search. So what is that algorithm? Those which algorithms which are developed for searching the items inside a data structure. Okay, to say about it, we have linear search, binary search, that one. Next is about the delete. So in all the data structures, we may have a specific rule to delete the data. For example, if I say the stack is like last in first out. Okay, so what, whoever comes last will be the first one to be deleted. So there I have to think that one, that considerations need to be there, and then only I can delete it. So it will be having different set of instructions to delete an element from a stack data structure, then a queue data structure. In a queue data structure it would be reverse, because that is working as a first in first out method. Okay, so whatever element is coming first will be the element to be removed first. So deleting the or delete operation performed on Okay. So delete operation performed on a, just give me a minute. So delete algorithm, which was written for to perform on a particular data structure, may not be applicable to another. Next, we have insert in the similar way. So that is the algorithm developed for inserting an item inside a data structure, and also updating. Updating, like algorithm developed for updating the existing element inside a data structure. Okay, so these are the major categories of algorithm. Under that, we have further different algorithm depending upon what way you are going to uh, perform those operations. Okay. Yeah. Next, we have about the algorithm is algorithm analysis. So the process of comparing rate of growth with respect to time and space complexity. What is algorithm analysis? Algorithm analysis is nothing but whatever algorithm we develop, it needs to be uh, it needs to be efficient in terms of time and in terms of space. Okay, so if the time is what to say, if the time is uh, it is more or it is less, I mean, if it takes lots of time to execute whatever algorithm which we have written, it is waste of time, correct? We are developing a solution, okay, for a problem because we want to save our time as much as possible. But whatever algorithm you're taking, you're manually. Okay, so here the problem is not at all solved. Okay, so what we are doing in algorithm analysis is we are comparing the algorithms rate of growth. Okay, what will happen? Okay, if the algorithm like if I give a particular amount of input to it, how the algorithm will perform? What will be its rate of growth in terms of time and in terms of space? The algorithm can be analyzed in two levels. That is, first is before creating the algorithm, and second is after creating the algorithm. So, depending upon whether you analyze the algorithm before creating the algorithm or after creating the algorithm, we have two things. One is priori analysis and posterior analysis. So, priori analysis means the analysis you will be doing on the algorithm before um, algorithm you actually create it. Okay, and posterior analysis means after once you create the algorithm, after the what after the what actual implementation of the algorithm, like not implementation, building the algorithm, you will be going to do the analysis on whatever algorithm you have, that is posterior analysis. So let's look into this. Priori analysis is the theoretical analysis of an algorithm, which is done before implementing the algorithm. Okay. Yeah. So we are just planning. We'll do this, we'll do that. Okay. Just we are saying it. And that's just the theoretical analysis we are doing. Okay. And with the help of theoretical analysis, we will be like, okay, the space complexity would be this much and time complexity would be this much. We'll be just having one assumption. That is because we are not implementing the algorithm yet in the priori analysis. But in the posterior analysis, it's not like that. Once we write all the algorithm steps, everything, we plan it. Okay, so then we will be doing the analysis on it. So in the priori analysis, various factors can be considered before implementing the algorithm, like processor speed, which has no effect on the implementation part. Got it? So processor speed, okay, for an algorithm would be what before implementing the algorithm. I don't have the algorithm within my hand, so how would be the processor speed will be affecting to my algorithm if I develop it like that? So that is the priori analysis. Next is the posterior analysis. Posterior analysis is a practical analysis of an algorithm. Okay, so priori comes under the theoretical analysis and posterior will come under the practical analysis, because in posterior what we are doing is, once after you do the actual implementation of algorithm, we will be doing the analysis. So the practical analysis is achieved by implementing the algorithm using any programming language. Okay, not only we are writing the steps of algorithm, but also we will be implementing it in a particular programming language. After that, we will be doing the analysis. So this analysis basically evaluates that how much running time and space taken by the algorithm. So that's the main motive of algorithm analysis. Just that you will be analyzing how much time a algorithm, whatever we have built, will be taking, and also how much space in the memory it is taking in order to save any inputs, whatever we are giving, or to perform some operations, if any extra like if any extra in variables are needed to store something at the time of operation. Okay, so all these things will be noted there. So now here we'll see in priori analysis and posterior analysis how it is depending with the different bases. So first is analysis time. So how what happens in the priori analysis and what happens in the posterior analysis. So analysis is done before executing. Okay. For example, the algorithm. Okay. And in posterior analysis, the analysis is done after executing, for example, program. So the step-by-step procedures will be there. We are thinking it. So the analysis time will be thinking with the help of the algorithm, and posterior analysis will be doing it with after the program. Next is the hardware dependency. So where the hardware dependency will come in the posterior analysis. Okay, because this analysis is independent of operating system and system architecture of CPU. Because in the priori analysis, we are not writing any codes. Okay, so we actually don't bother about it. Okay, but then in the posterior analysis, we will be implementing it, and when we are actually running it, we have to see how much time it is taking. Okay, so one analysis I have already done in terms of the algorithm. Second analysis I'll be doing when I actually run it on the hardware. So how much time it is taking now. So depending upon that, I have to either change the things in the algorithm, or else I have to upgrade my hardware so that it matches with my algorithm, whatever I have built. Because not every algorithm will support whatever hardware we are having, whatever missions we are having. Because depending upon the problem, to solve a complex problem, we need high computational power. So the hardware may sometimes not go along with the algorithm, whatever we have. Okay. Yeah. Next thing is about the cost. So related to the cost, what happens in the priori analysis and what happens in the posterior analysis. So in the depending upon the cost, this analysis is cheaper because there is no additional requirement of software and hardware for execution. Yeah. So like how much does it cost? Okay, depending upon the priori analysis. Okay, because we are not implementing it anywhere, we are not running it anywhere, so the cost is very less. And in the posterior analysis, the costly because additional requirement of software and hardware for the execution is needed. And as a basis of uniformity, the priori analysis will always provide the uniform values, and the posterior analysis will provide the non-uniform values. Okay, because we are actually implementing it, and sometimes some external factors may affect us from whatever theoretical analysis we have done before the implementation. Okay, that is nothing but whatever priori analysis we have done. So priori analysis will give the uniform values, and posterior analysis will give the non-uniform values. Yeah. So now to talk about the algorithm complexity. So the algorithm analysis is done. Now algorithm analysis will be depending upon when you are doing exactly the analysis, we have priori and posterior analysis. Now we have the complexity. So how complex an algorithm is. In algorithm analysis, we are doing the same thing. We are finding the complexity. Okay. So the performance of the algorithm can be measured in two factors. That is time complexity and space complexity. Okay, so to put it in simple words, it's nothing but time complexity is nothing but how much complex time it takes. Okay, the complexity of the algorithm in terms of the time we are checking. The metric here considered would be the time, and in terms of the complexity for the space would be the metrics. What we are considering there is a space. Okay, yeah. So in detail, we will see what exactly time complexity and what comes under time complexity and also the space complexity. Okay. And apart from that, we will be learning some other topics also, which I call it as asymptotic notations, which is nothing but to depict the time complexity and space complexity. Even if I measure the complexity, I need something to show, right? This is the complexity. So whenever I write algorithm, one particular algorithm analyst will write what the complexity regarding the time and space. So we need something to show that. So this and along with the asymptotic notation, we will discuss this topic in the next class. Okay, that's all for today. Thank you.